So we are in Statistical Rethinking, second edition, chapter 13. And here we will deal with the questions 13M1 as well as 13M2. Okay, so here is the question for 13M1. Right? So we're going into a data set that was presented earlier in the chapter, reedfrogs. Okay, and we actually had a model that was model 13.2, which I've reproduced with only some minor modifications to the name of some of the parameters right there. Okay. And so now what we're asked to do is to go and modify the model by adding different predictors, including predation, the size, which is, I believe, the size of the tank. Okay. And we're supposed to consider just the individual main effects, so one model with predation, one with size, one with both of these main effects, and then one with interaction terms. Okay, and we're told that we're not supposed to focus on the inference of these models and the predictor variables and the different predictor variables across the models, but to instead focus on the variation across tanks. Okay, and explain why it changes as it does across the models. Okay, so you can look at all of this for yourself and kind of dig into these different models. But roughly, I've just started with model 13.2, and then I've added predation in one model right here. I've added just tank size in one of the models, okay, right here. So there's big and there's small. So to codify tank size, I've made small tanks 1, index 1, and then big tanks index 2. Okay, so we have that. And then we have predation and size. So now in the linear model, I just have, I'm just combining the main effects here. Okay, and then predation time size, where we have the interaction. So to do that, so to get the interaction, I have indexed my predation variable by tank size. Okay, so we'll get different beta estimates for both tank sizes here. Okay, all right. So so we're going to run that, and the question I found a little bit confusing when it says focus on the inferred variation across tanks. And I believe what this is asking us to do is to compare these sigma values, which are which are supposed to be the standard deviation of tank, basically. Well, not just tank, but anyway, well, yeah, the variation within the tank, so sigma tank. Okay. So, so I've ran all of these models, and we're just going to look at the sigma tank output here. And so I'm just using the plot coefficient tab here. I'm just plotting the sigma tank parameter of each of the models, and here's what you get. So you get this very distinct pattern here, where whenever the model includes predation here, here, and here, the variation across the tanks is reduced compared to when predation is not in the model. Okay, so this suggests then that predation is actually doing some work, right? Because it's reducing the unexplained variation sigma across tanks, right? Okay. So now in 13.2, we're supposed to compare these different models using WAIC, and so I've done that here, and we'll look at that in just a second. And then we're supposed to reconcile the differences in WAIC with the posterior distributions of the model. Okay. The second part, again, I'm not really sure what that means, and so I kind of stumble my way to an answer. But so let's compare these different models. Okay, that's what I've done here, and I've just rounded it off to 2 decimal places, so it's easier to look at. And we see the WAIC scores as well as the ranks of the different models. Okay. And we see that that the models with predation are typically scoring better than the models without predation, okay, which very much mirrors what is happening here with the sigma values, right? There's less variation among tanks when predation is entered into the model, okay? So that's interesting. And so now we have to reconcile the differences in WAIC values with the posterior distributions. Okay, so I'm not really clear what this means, and so, or I think maybe I have a grasp on it now, but in order to kind of get to where I kind of understood the question, I just started looking at the posterior distributions. So now I have the posteriors from each of the models, and I've just ordered them here in terms of the ordering that was given on the WAIC output. Okay. And so now this involves a lot of scrolling because you have to get depth equals 2 to get to some of the parameters we want, but part of depth equals 2 is is the intercept for each tank. So we have to scroll to the bottom of each of these Preci outputs, unfortunately. But we're just going to look at the beta predation and the alpha tank, or no, alpha size parameters. Okay, so here's beta predation, and we see that it's reliably negative. Okay, so for one of the models it is, at least, right? So for the first model. For the second model here, the interaction model, we have two estimates for beta predation, and we see that both of those are reliably negative, but the ones for size, right, are, you know, pretty ambiguous, right? Really straddling 0. Okay, so that's for the interaction model, and we'll just see if this trend continues. Okay, so once again, we see beta predation is reliably negative, and the size intercept is very ambiguous. This is a model, so this is the model without predation or size, so we're just going to skip over that. And then we have the model with just size, and even here we see that it's pretty ambiguous. Okay, so in the WAIC comparisons, if I can scroll up that far, in WAIC comparisons, we saw that the models with predation are generally scoring better. When we were comparing the sigma values of the different models, we saw that the sigma values were reliably smaller. In other words, there's less unexplained stuff happening in the data when we have predation in there. Okay, and now we see that all of the beta predation parameters are reliably negative, right? And so all of these indicate that that predation is really explaining something in our data set. Okay, we'll call that good there.